Finals in Algorithms and Complexity. Hi everyone! Hi Prof. Doc Alagos. Now, I'm going to present about algorithm, flowchart, and pseudocode. Presented by me, Herby G. Estrella, BSCS 3 New Mod, First Year, Second Term, 2023-2024. First is flowchart. It provides a pictorial representation that transcends the confines of traditional programming languages like C, C++, Java, and Python. By offering a visual depiction, flowcharts afford a holistic view of an algorithm's execution flow, making it easier to understand and analyze complex procedures. They act as universal language, bridging the gap between technical and non-technical stakeholders, enabling effective communication and collaboration in problem-solving endeavors. Algorithm. It delineates a systematic, step-by-step procedure devised to tackle a specific problem or task. Algorithms serve as the blueprint for computational processes, encapsulating the logic and sequence of operations required to achieve a desired outcome. Pseudocode. Pseudocode is a high-level description of an algorithm that uses a mixture of natural language and programming language like syntax. It's less formal than actual code but more structured than plain English, making it a useful tool for outlining the logic of an algorithm before implementation. Procedure. It is instructions that are crafted with the precision and clarity necessary for execution within a finite time frame, ensuring predictability and repeatability in the algorithmic process. A well-structured procedure forms the building blocks of algorithmic solution, laying the groundwork for efficient problem-solving methodologies. To navigate the intricacies of flowchart design, one must understand the core components that comprise these visual representations. Flowcharts leverage a variety of symbols to denote distinct elements of a process. Understanding flowchart components. Terminal or curved rectangle. It is a symbol marks the initiation or culmination of an algorithm, providing clear demarcation for its beginning and end. Input or output or parallelogram. It is signifying operations involving data entry or output, facilitating interaction between the algorithm and its environment. Process or rectangle. It represents internal computations or actions performed within the algorithm, encompassing calculations, assignments, and other manipulations of data. Decision or diamond. It denotes branching points within the algorithm where different paths are pursued based on specified conditions. Connector. It serves as bridges between different segments of a flowchart, facilitating seamless transitions and organization, particularly in multi-page flowcharts. It's like if the whole canvas or paper that you are working with doesn't fit your flowchart of how big or many components you put, use this instead for a neater format of transferring the other parts of your flowchart to a more wider space canvas or paper. Control flow or arrows. It depicts the directional flow of the algorithm, guiding the reader through its sequence of operation and decision points. These components form the visual language of flowcharts, enabling concise and intuitive representation of algorithmic processes. Example: weekend plans. Algorithm in simple English. The algorithm expressed that weekend planning algorithm begins by brainstorming potential activities and checking the weather forecast. Based on the weather condition, whether outdoor or indoor activities are planned accordingly. Factors such as friends, preferences, and availability are considered before finalizing the plan. The process includes once the plan is settled. You can see the flowchart on the picture. In pseudocode, start, brainstorm potential activities, check the weather forecast, if good weather or bad weather. If good weather, plan outdoor activities, else plan indoor activities. Consider preferences and availability of friends. Finalize the plan. Stop. 2 is grocery shopping. Algorithm in simple English. The algorithm expressed that the grocery shopping algorithm begins with making a shopping list and driving to the store. Once inside, items from the list are retrieved. If all items are obtained, the process proceeds to checkout. Otherwise, shopping continues. After paying for groceries and exiting the store, the journey concludes with driving back home. Now we can see the flowchart in the picture. In pseudocode, start, make a shopping list, drive to the grocery store, enter the store, retrieve items from the list. If all items are collected, proceed to checkout, else continue shopping, pay for groceries, exit the store, drive back home, stop. The third one is palindromic number. Algorithm in simple English. The algorithm expressed that to determine if a number is palindromic, start by inputting a number and storing it separately. Reverse the digits of the number and check if the reversed number matches the original. If they match, the number is palindromic. Otherwise, it is not. Then conclude the process. The flowchart is in the picture where you can see the given number 3. In pseudocode, start, input a number, store the number in a separate variable, reverse the digits of the number. If reversed, number equals original number, output palindromic, else output not palindromic, stop. The fourth one, Armstrong number. Algorithm in simple English. The algorithm expressed that to determine if a number is an Armstrong number, begin by inputting the number and storing it separately. Then calculate the sum of each digit raised to the power of the number of digits in the number. Check if this sum equals the original number. If it does, the number is an Armstrong number. Otherwise, it is not. Finally, conclude the process. The flowchart in this number is seen in this picture. In pseudocode, start, input a number, store the number in a separate variable, calculate the sum of each digit raised to the power of the number of digits. If calculated, sum equals original number, output Armstrong number, else output not Armstrong number, stop. Last example is volume of a cylinder. Algorithm in simple English. The algorithm expressed that to calculate the volume of a cylinder, start by inputting the values for its radius and height. Then compute the volume using the formula volume equals pi times the radius squared times the height. Finally, output the calculated volume and end the process. And the flowchart in this one is in the picture down below. In pseudocode, start, input radius and height of cylinder, calculate volume equals pi times the radius squared times the height. Output volume. Stop. Everyday use of the lesson. Flowcharts, algorithms, and pseudocode play integral roles in various everyday activities and workplace scenarios, aiding in the systematic organization and execution of tasks. In everyday life, processes like cooking recipes, home repair tasks, or even planning a commute can benefit from flowcharts to visualize the steps involved and algorithms to streamline decision-making processes. For instance, in software development, designing algorithms and writing pseudocode helps developers outline the logic of their programs before actual coding, ensuring smoother implementation and easier debugging. Thank you for listening. Please comment down below what are your more questions. Submitted to Prof. Doc Alagos. Thank you for watching.